Welcome to today's webinar. Our focus today is going to be the Industry 4.0 in the cloud. What we'll be talking about is how AWS has actually been able to help many of our customers with factory transformations. I'm Douglas Bellin. I look after our industry solutions globally within AWS and work many times with our customers out there. What we're going to be talking about is how AWS has enabled many of our customers with factory transformation or digitization of what people are looking after. There's really two major values that any manufacturer will look at when they look at why they want to move into a digital format. You have two major areas, either grow your revenue or decrease your operational overhead. Within those major buckets, there's a lot of different use cases or capabilities that customers go after. When we look at growing our revenue, we look at things like how do we make our sales teams better? Start having them become more digital, become more data-driven at the same time. Looking at how they can be empowered to make better decisions across the board with their customers and truly build a better relationship with their customer. Once they understand how their customers are using their products, the focus then turns into how do I make better products faster to the market so we're ahead of our competition. When customers are looking at decreasing operational overhead, these include things such as reducing your cost of doing your business. This could be shrinking inventory. This could be making sure that we don't have scrap and other capabilities out there. A number that almost every manufacturer has is OEE. And how do we increase that overall equipment effectiveness? That's a focus that people look at, and being able to be data-driven is going to be a driver for that OEE capability. Most customers, as they are bringing more products out, they of course want those products to get better with time. Now, those could be existing products that we'll talk about that have capabilities, such as how do I do an upload or actually add more capabilities for that customer and how they're using it. And driving everything across the board, becoming data-driven. Part of this is due to the fact that many of the environment that we work in is starting to be grayer and grayer. We've been talking about the people retiring in the business, and it's happening at a bigger accelerated rate right now, and we do want to make sure that this is no longer a gut instinct, but really driving towards a data-driven discipline in our operations. When we look at the Industry 4.0, which is a coined phrase out of Germany, but also has a lot of other capabilities. So Industry 4.0, Society 5.0, and other things in other marketplaces. We feel that cloud is a big enabler for the type of capabilities that people are looking for. When we look at autonomous robots, simulation, vertical and horizontal integration, looking at the industrial Internet of Things and cybersecurity, looking at how we're working with customers around 3D printing or additive manufacturing. And then ultimately, where people are headed towards is around AR and VR and building those capabilities in to have that new experience as people go forward. All of this, of course, is being driven by big data and analytics. And the great place to store this and to have these capabilities go across the board is really in a cloud environment. In the manufacturing environment, this has really started to accelerate over the past 2 to 3 years. We're starting to see more and more customers move away from having those capabilities on premise, moving into using what cloud is bringing you with the full capabilities, giving you virtually unlimited compute and virtually unlimited storage capabilities. So now you can start looking across what used to be silos of information. This is really starting to drive customers' new insights and new capabilities that they couldn't see in the past. When we look at this, we look at a couple different areas. One of the areas that we focus on with our customers is around smart factories. And this is working with our customers to understand what's going on the plant floor and understanding the type of capabilities that are happening off that plant floor. Once we have that capability become data-driven, we're starting to see more and more value from our customers. But this isn't easy. Smart factories is a concept that's been out for a long time, and digital factories is a driver in that area as well. As I said, it's not easy. So what people always have is downtime. So how do you shrink that downtime? How do you ensure that your products, your people, your capabilities are running truly at top performance? There's legacy equipment out there. In fact, according to a lot of analysts out there, IDC, Gartner, ARC, LNS, and others, the average machine age is 18 years old. That means a lot of your machinery, as you very aware of, do not have an RJ45, an Ethernet port on them. Very rarely would they have even a wireless access point on them. So how do we get to that data? And of course, there's the security concern. How do we make sure these devices and data is secure? Up until probably 10 to 15 years ago, again, these devices weren't even connected to a network. So now what we're saying is no longer just connected to a network, but now make that network accessible over the internet as well. That scares a lot of people. So what we need to be able to do is ensure that what we're bringing to the market is secure, is updatable, and is something that can be driven with that legacy environment to help with that downtime and being able to bring those capabilities so customers can start to change their businesses going forward. When we look at smart factories, this is an example of what happens out in the field. You've got multiple locations. You have multiple machinery out there. The goal that everybody wants to get to is a single source of the truth. So we see the AWS cloud in the middle there, aggregating that data from plant 1, plant 2, plant 3, and so on across the board with that. Concerns that operators are looking at are things like production targets. Can I meet the production target that we actually have committed to? Or can I actually use a different line to actually supplement or augment the capabilities that we need on line 1, line 2, or line 3? I mentioned OEE earlier, and that every manufacturer has that as their target for them. But the problem is each plant many times actually calculates OEE on their own. With this view right here, what we're able to now do is actually give a enterprise view of what's going on for OEE. That now is allowing compare and contrast across those different facilities, across the different products that are being made, and across the different users and how they're actually making product as well. Every manufacturer has a quality concern. They want to make sure that they are at top quality of the products that are coming out. Again, many times those different plants look at these different quality numbers and calculate those differently. So what we want to be able to do is work with customers, again, build that single dashboard instead of having to go out and have that dashboard built at every location. This then starts driving into workforce efficiency of how good are our users? Are they effective? Are they actually doing the right products and the right capabilities in the right time? Can we share best practices from location 1 to location 2? And are those best practices data-driven? If you look at anybody's annual reports, everybody has sustainability metrics. So how much energy are we using? Can we use less energy the year after? Can we use less water? Can we ensure that what is going back out into the environment doesn't have any issues with it? So those are things that people are looking for, and this is how we're looking at many architectures and many factories across the environment for our customers. And how do we do this? Well, we do this by scaling across an architecture which comes to play both from an on-premise capability for data acquisition, but then also a data storage capability. So if we start at the right-hand side over here where it says factory machines, again, what we need to be able to do is both connect to new machines as well as legacy equipment. These could be some of those non-digital equipment out there that we need to connect to get the data off of. So are those sensors that have to go on there or other things from there? Greengrass, our IoT family, actually goes in and has a connector product to be able to go down and attach to those machinery and be able to have those connectors for those different providers out there. So is it Siemens, Rockwell, Emerson, Honeywell, and others that we have to have the proprietary connector built into it so we can get to that data and start aggregating that data at the edge. Greengrass Edge, or the gateway that sits right next to that, actually can now start going in and start empowering and enabling that data. Start adding new, rich information to that data so we can start looking at the data across the board. Most users really are not concerned about what that product is at the endpoint. So if it's a Rockwell controller or a Siemens controller or somebody else's controller, what they're looking for is the data that comes off of there. So what we want to be able to do is normalize that data as close to data creation as possible. Once we have that data normalized, we can then push this over our IoT core into our analytics capabilities to start building business logic and other areas onto that to start changing our business. Some of this data could be coming off of our historian products. Historians are incredibly powerful data sources for us to go into. With very low disruption to your operations, very minimal downtime, we can start getting into that data, but then unlocking that data and enriching it again in a cloud environment and a data lake. We can then start adding into that data lake other capabilities, such as maybe our ERP systems, our planning systems, our production systems, and everything from that standpoint. Again, this is a way for us to build that single source of the truth of the data so we can start asking new and unique questions across that. The bigger square on here is really where that data lake sits. So you have multiple technology that start to come together where we use lake formation capabilities to build that data lake for you. That can be a managed service where we can actually run that for you and allow you to get back to running your business, not get back to running your operational capabilities. These products could be smart products that maybe are our partners that are giving to us to be able to drive in those new capabilities. Ultimately, what we do want to have, though, is again that enterprise view of those capabilities from there. Now, this is if you're running a facility. So, a lot of times, though, you may have products in your facility which others are actually working for and bringing to you as well. Now, this could be products that you're making. This could be your robotics. This could be your conveyor belts or other systems that you have in place. The goal here, and what we're talking about with many of these providers, is actually moving away from a pure capital intensive capability and moving more into an operational expense. So this has happened in the software business where everybody talks about software as a service. What we're looking at is how this becomes a product as a service or machine as a service type of capability. We have many customers that are coming to us and saying, I only have one of these machines. I want to fine tune it and make sure that it's actually optimized for my operations. What we then do many times is work with the producers of those machines to have that capability involved with that machine, unlock the data that's on that machine, share it between both the provider as well as the person who's running that operation. And now, looking at that same architecture, we look at that overall view of where things are going. No longer are we looking at the plant level, but now we're looking at a machine level. So the orange boxes are down to those machines. We may have multiple of those machines in those environments. The provider of that machine probably has a service level agreement with you that has to become a data-driven environment. So that could be uptime, that could be quality, that could be products that you're being produced and certain outputs or outcomes from that capability. This starts to change the capability of how they're pricing to you. They could actually price by item that's made. Or if you're a conveyor belt maker, maybe you're doing it by the linear foot of boxes that are moving. This actually shares the risk reduction between you and the company and actually makes it easier because you're guaranteed more of an uptime capability. Concerns that the providers will be able to bring to you or outcomes that you're looking for would be things like energy consumption and how can you be optimized to do better energy capabilities. Could be predictive maintenance. So they understand that machine probably better than anybody else out there. They've created that machine. They know the ins and outs of it, but they may not know how you're using it perfectly every time. So here, what they're able to do now is start doing predictive maintenance for you. Start understanding when this machine may fail in the near future, and they could actually stage parts for you or stage downtime instead of having unplanned downtime capabilities. This truly builds a machine as a service offering. And we see many customers moving towards this. We see people doing this across multiple environments. And this is really what we're seeing also happening for products that are being built for customers as well. So this could be as simple as something like your attached thermostat at home. And that becomes a machine as a service. We're seeing people doing this with things like conveyor belts, as I mentioned, with elevators and other systems where they're now no longer buying those, but they're actually buying the outcomes of those capabilities. But what this means is, again, that it has to be data being delivered in a secure manner to be able to allow that remote operation and remote maintenance from the person who's providing that machine for you. To support this, again, we've taken the architecture that we looked at from before and changing some things on it. You're still looking at the factory machines up in the upper right-hand corner, the upper left-hand corner, where you have the factory machines with green grass connectors, with the green grass edge, pushing that data back now into your provider's data lake. Again, this could be a unified data lake for you and your provider of that machinery. So you have your smart products over on the right-hand side, which is now bringing that capability into your environment so you can have that looked at and driven as you start to move forward as well. Customers are changing the insights that they're getting, but it still needs to be important information that's driven into their production planning. So no longer is this data locked and unaccessible. This data has to be accessible by both you, the person buying that machine or renting the time off that machine, but also accessible from the machine operator as well, or the owner of that machine. So if you're only buying widgets coming off the line and you want to have that information shared between you and that provider, that has to happen in a secure environment. The data lake can be federated so you can only see your information from a security standpoint and not other players as well. Now, to support this with many of our customers, we also work across actually product design. So many of our customers, as you're designing products, and the historic way to do it was you had a workstation that sat under somebody's desktop. That workstation basically was there and it did most of the compute power for you. Some companies would have a high performance compute cluster where you'd have the data stored up there. You'd have some scheduling time that you would then put a project up to there. Now, this could be 3D graphics. This could be rendering of a machine. This could be looking at plant operations. This could be product design and other things from that standpoint. The problem with this is that many times you had to buy for the maximum level, and you didn't know what that maximum was. So sooner or later, you all of a sudden had to add more and more and more into that high performance computing cluster, or more storage, or more sharing file capabilities from there. So what AWS brings is actually an unlimited storage capability for you, an unlimited compute capability. We have ways where we can move this using our Snowball or our Direct Connect, where we can actually bring a physical device into your environment, attach to your data center, and take the data from your data center and bring it back into an Amazon environment. This instantly would create your cluster for you. We'd have our auto scaling. So if one day you need a certain level, but the next day you need something twice as big or 3 times as big, you could actually provision that instantly or close to instantly to be able to use those type of capabilities. No longer do the users need a high performance workstation under their desk. They could use thin clients or zero client capabilities because all of the computing is now done on the AWS cloud environment for you. So this is a way for you to be able to scale, not have to worry about getting to a point of max, but also allow more users to have these capabilities. You don't have to worry about scheduling and having those type of capabilities move forward because you basically have that virtually unlimited capability. Once customers have that product designed, they can then go into production design, and from production design into production capabilities. Part of the overall arching story that we talk with many of our customers is also around SAP. SAP, for you guys, the customers out there, have put a deadline of 2025. 2025 is the time frame where SAP says no longer will you be able to use relational databases. You have to go into a HANA environment. So to migrate to S4 is not an easy migration. But what we're looking at is how do we reduce the cost, again, using our cloud environment for you to have that virtually unlimited capability, but also improve the agility that your customers are looking for. SAP does lock you in a little bit, and you do have some tight constraints about what you can do within that environment. So what we're looking at is how we can bring the digital transformation from an SAP environment where HANA is going to give you more speed, more capabilities, and some more things from that standpoint. We can spin up a HANA instance for you to test in less than an hour. So customers use this to be able to go and see if that environment is right for them or understand what the nuances or the differences are across their capability as well. They can scale this up and also scale it back down very quick and easy with a very low cost of entry. So this is not building a data center. This is not trying to buy the right hardware. We have that for you at your beck and call. We can clone systems. We can upgrade systems. We can change what's going on that system from a workflow standpoint. Many of our customers actually bring in a basically disposable environment running HANA for them to be able to test. What they're able to do is also then look at what they're doing from a digital transformation standpoint to fine tune how the SAP system is actually affecting that. So instead of being stuck with the system that you have, you can now actually start doing some of your changes building your change requests very quickly and easily, testing it out, and then bringing it from a test or a dev environment to a live environment very quickly and easily. We're seeing more and more customers move towards this route, both from a lift and shift standpoint, so moving from relational to relational, but also from a lift and migrate standpoint. So moving from an R4 or an R3, which some customers still have, into that S4 or HANA environment. We have plans and capabilities to actually work with customers and partners that allow this to happen from that standpoint. In 2018, we actually started a new process and a new program called the Industrial Software Competency Program. We know this is something that has to happen with partners. This can't be just an AWS environment. This can't be just the wrong guys in the wrong areas to be able to work forward as we go forward. What we've done is actually work with a handful of partners to bring them up into our industrial software program. And these are special partners for the manufacturing environment that do things like Autodesk with high performance computing for things like, how do I do my 3D rendering? How do I do my design plans and everything from there? It looks at other companies like Infor, which has an ERP system, which now is delivered over AWS. Or Siemens with their MindSphere product for their MOM or Manufacturing Operations Management System, which is delivered over AWS to give you that new insight of those capabilities. So exactly what I was talking about from earlier, for you to be able to buy something very quickly and then deploy it and be able to deploy at mass across all your environments. So what AWS is also looking at is no longer just being a building company, but looking at how we have extension capabilities for you to buy products such as our partners here, but then add to them the extended capabilities, which may not be part of the core product out there. If I take 42Q as an example, 42Q is a partner of ours that actually has designed an MES product for the cloud. So no longer does this have to run on every desktop or every laptop sitting next to the machinery. It can have an open connection right up to the AWS environment where 42Q would be running with the execution system to allow you to take the capabilities from there. Once that system is now on AWS, we can start adding new capabilities such as AI and ML. That could be another partner of ours, such as Foghorn, who has IoT and AI and ML capabilities together for us to be able to bring those capabilities and scale what you're trying to do in your business to be able to change those new capabilities from there. We're constantly adding to the software competency program. So as we go forward, I see more customers getting this and having these availability for them to be able to do things very quickly and easily as they go forward. A great customer that we've had over the past couple of years is Georgia Pacific. May not know Georgia Pacific by name, but you probably use them every day. They're one of the world's largest producers of tissue paper, packaging paper, toilet paper, building products, and other type of things that go in from that standpoint. So if it's got some type of paper backing on it, some type of capability from there, this is what they produce. They do hundreds of thousands of toilet tissue, paper tissue rolls per day. It's an incredibly complex system. You have miles of rolling and miles of systems that start to come together. And if a break actually occurs in that roll of paper, they have to start over. They have to go back to the system, and the downtime can cost about $250,000 per day. So they looked at this as a way to start doing predictive maintenance, start doing predictive quality on those machines so they don't see a downtime. What they wanted to make sure is try to get away from those breaks and start fixing the machinery or actually optimizing the machinery so that break doesn't happen as they go forward. This also helped them with better quality of their products as they go to their customers, which I'm sure everybody out there who uses these type of environments is very happy with as well. What we did together with Georgia Pacific and a couple of our partners was we actually had Kinesis down to the machinery out there. So if you remember from the architecture slide in the upper left-hand side where you had IoT or IoT gateways running Kinesis to be able to attach to that machinery, bring it into our simple storage or Amazon S3 to bring that data to allow it to have both structured and unstructured data for analysis. Some of this unstructured data is video or photo that is starting to happen that they're streaming live into S3 to be able to do AI analysis of that to understand where a tear or a break might be occurring. We use MapReduce to transform the data, which then starts going to have that data be able driven into Redshift for that data storage standpoint. On top of all that, we have SageMaker, which actually goes from a machine learning standpoint to build, train, and deploy their models at scale. This has been incredible for them in one location. And by you being able to use the same architecture across their other locations, they're now deploying this to their other hundreds of locations as they go out to market. The results that they've been able to see over the past 6 months is a 30% paper product tear reduction, which also means an uptime capability of hours that they didn't have from in the past. They've stated that they've been have increased profit by millions of dollars for one production line, and they have a few hundred more production lines that they want to be able to build this in as they go forward. They're also having the issue of people retiring, people no longer wanting to work, 8-hour days, 40-hour weeks, and so on from that standpoint. So this is because it's being automated, they're less dependent on these factory experts or on that process expert, and they can keep the lines running optimal and efficiently across all of their environments. They can actually predict now equipment failure 60 to 90 days in advance. What that's allowing them to do is actually build planned downtime for when those multiple failures might occur across that equipment. Again, that helps them with the quality capability, that helps with the uptime capability, that helps with their productivity overall as they go forward. This ensures them that they can have the highest quality products that should be running at the best lines at the fastest rate, so they actually can deliver to the customers what they want. Steve Bakalar, the VP of IT and Digital Transformation at Georgia Pacific, states, overall, using AWS, we can ensure the highest quality product is running at the fastest possible rate so that we can best serve our customers out there. Steve's been a great advocate for us across the board and has really pushed us to look at how we're deploying with our customers in new and unique ways across the board. With this, thank you very much for your time. For more information, please go to aws.amazon.com/manufacturing. You'll be able to see more information of what we're doing with other customers. You'll see more of our customer use cases out there. You might see somebody in your business doing something that you haven't thought of as well. So please enjoy that and be in touch.